Probability of disjoint and overlapping events. All right, this lesson has one state standard, and actually we're going to learn about this standard a little bit later, but this lesson is going to prepare us or get us ready to learn about this standard. This lesson, the success criteria, explain how disjoint events and overlapping events are different, find probabilities of disjoint events, find probabilities of overlapping events, and solve real-life problems using more than one probability rule. New vocab that you need to know: compound event. The union or intersection of two events is called a compound event. Overlapping events. Two events are overlapping when they have one or more outcomes in common. A disjoint event. Two events are disjoint or mutually exclusive when they have no outcomes in common, as shown in the third diagram. All right, so as you can see, the third diagram here, intersection of A and B is empty. This is considered a disjoint event. This is when no outcomes are in common. Looking at the other diagrams, you can see here the intersection of A and B. You can see A and B do have some things in common. So these four dots here are included in A and event B. So that's going to make a difference a little bit later. Here we have a union of A and B. Okay, that's like two people that get married. All of their assets are joined, so they then have more things to access all together. So union of A and B includes everything in both A and B. And then, of course, once again, the intersection of A and B is empty. That's when there's no overlapping. There's no intersection here. Key idea that you do need to be familiar with: probability of compound events. If A and B are any two events, then the probability of A or B, or is the key word here, A or B, is probability of A or B equals probability of A plus the probability of B minus the probability of A and B. If A and B are disjoint events, then the probability of A and B equals 0. That means the overlapping part is 0, like right here. Then the probability of A or B is the probability of A plus the probability of B. So two different formulas there, slightly different. The first one just subtracts this middle area here because it is overlapping. The disjointed doesn't have any overlapping, so you just add probability of A plus probability of B. Example 1, finding the probability of disjoint events. A card is randomly selected from a standard deck of 52 playing cards. What is the probability that it is a 10 or a face card? All right, so we need to know the probability that it's a 10 or a face card. All right, so how many 10s are in a deck? So you're going to have 10 of spades, 10 of hearts, 10 of clubs, and 10 of diamonds. So there's going to be 4 different ones. All right, so let's start by assigning event A. So event A is going to be, it's going to be a 10. So event A is going to be selecting a 10. Let's say drawing a 10. All right, and event B is going to be a face card. Selecting a face card. All right, so once again, so we're going to have a 10 of spades, a 10 of hearts, a 10 of clubs, and a 10 of diamonds. All right, so we know there's going to be 4 out of the 52 playing cards are going to be the chances of, or the probability of drawing a 10. All right, let's look at face cards. So we have jacks, queens, and kings. And we have 4 suits of each of those 2. So let's say we have a jack of spades and a jack of hearts and a jack of clubs and a jack of diamonds. And then we're going to have a queen, 4 queens, and 4 kings. All right, so we're going to have a queen of spades, hearts, clubs, and diamonds, and a king of spades, hearts, clubs, and diamonds as well. All right, so these are our face cards. And these are our 10s. All right, now that we have all of that, that's our sample space. And we want to know the probability of what is the probability that it is a 10 or a face card? Or tells us that this is going to be the probability of a compound event. All right, so we're going to do the probability of 10 plus probability of face card. All right, so 10s again, if we look up here, we've got 1, 2, 3, 4. 4 out of 52. And then face cards, we've got 1, 2, 3, 4, 5, 6. So we've got 12 face cards. 6 times 2 is 12. Or you could do 3 suits times 4 of each of those, so still 12. All right, we could reduce that, but since they already have a common denominator, let's just add straight across. So remember, when you're adding fractions, add the numerator, keep the denominator. 4 plus 12 is 16 over 52. Okay, 16 over 52. Both those reduce by 4. So we can reduce that to 4 over. 4 goes into 5 one time. And 12 goes into 12 3 times. So 4 over 13. And we can see what that equals here. So let's say 4 divided by 13 is going to be about 0.308. And if we make that into a percent, that is about 30.8%. So that tells us that the probability that a randomly selected card is a 10 or a face card is about 30.8%. Example 2, finding the probability of overlapping events. A card is randomly selected from a standard deck of 52 playing cards. What is the probability that it is a face card or a spade? So the probability that it's a face card or a spade. All right, so again, we're going to have to think about what is our sample space. So when we talk about face cards, the face cards, we have jacks, queens, and kings. So we can have a jack, a queen, and a king. So we have a jack, a queen, and a king for, let's say, hearts. And let's say diamonds. And clubs. And spades. So we're going to have a jack, a queen, and a king of spades. And you can see I kind of put that in the middle because we're looking at two events, and a face card can be a spade as well. So these are all of the events for face cards. And then let's say this is event A is a face card. And event B is a spade. All right, so this is event A. Kind of hard to read that there. I'm going to write that again. There's A. And then we're going to look at all the cards that could be spades. So you know any card from 1 to 10 can be a spade, but we don't start with 1. We start with an ace. So you have an ace, a 2, a 3, 4, 5, 6, 7, 8, 9, 10. And then you go Jack, Queen, King. So ace of spades. All of these are spades. And these are spades as well. So you can see this does have some overlapping. All right, so event A again is all your face cards. Okay, jacks, queens, kings, with hearts, diamonds, clubs, and spades. And then this is our ace, 2 through 10, and then king, queen, and jack of spades as well. So this is event B. All of our spade cards. This is all of our face cards. And then in the middle here, these are the ones that overlap. All right, so we want to find the probability of face card or spade. So probability of, I was going to say event A, but let's just say face card or spade. All right, and because this is a disjoint event, meaning it's not a disjoint event, sorry, meaning that it does have some overlap here, we are going to have to subtract this middle part here. So we're going to have to use this first formula, probability of compound events. If A and B are any two events, then the probability of A or B is probability of A or B equals P of A plus P of B minus the overlapping part, A and B. All right, so let's first see what is the probability of event A. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's going to be 12 out of the 52 card deck. And then we have plus the probability of B. Right here, we're going to do plus the probability of B. So that's spades. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So there's 13 out of 52 cards that are spades. So 12 face cards, 13 spades altogether. Now we have to subtract the part that are both spades and face cards. So that's going to be 3 out of 52. All right, so 12 and 13 is 25. 25 minus 3 is 22 over 52. And that's going to be approximately 0.423, which is about 42.3%. That a card is both a face card or a spade. And you can see here the common error is a lot of times people add these two event spaces and they forget to subtract. So make sure you know that that's not just P of A plus P of B.